Compound interest. Use the compound interest formula A equals P times 1 plus R over N to the N times T power and A equals P times E to the RT power to solve the problem given. Round answers to the nearest cent. Find the accumulated value of an investment of $15,000 for 5 years at an interest rate of 4.5%. We're given 4 scenarios. The first scenario is part A, and that is compounded semi-annually. Now first, compound semi-annually means that we're compounding 2 times a year. And N represents the number of compounding periods in our formula, so N is going to be 2. Now we're going to use this first formula because the second formula is only for compound continuously. All other compounded scenarios are going to fall under this first formula. So we've already identified N. Now we're going to identify P, R, and T. P is the principal, or the initial amount that you're investing. And in the problem, it tells us that we have an investment of $15,000. So P equals $15,000. And it says it's for 5 years, and T is the number of years, so T equals 5, and we have an interest rate of 4.5%. So R is 4.5%. Now in order to plug R into the equation, we have to convert the percentage to a decimal. So in order to convert percentages to decimals, you just take the percent, 4.5, and divide it by 100. So we get a decimal value of 0.045. Now we're going to take all these values and plug it into our formula. A equals P times 1 plus R over N to the NT power. And A is what we're solving for. That's our future value. So when I plug all my numbers in, I get 15,000 times 1 plus 0.045 divided by 2 to the 2 times 5 power. Our first step is to divide 0.045 by 2. When we do that, we get 0.225. Next, we can multiply 2 times 5 to get our power of 10. Now we want to work on parentheses some more and add 1 to the decimal. When we do that, we get 1.225. Now we have A equals 15,000 times 1.225 to the 10th power. Next, we're going to raise 1.225 to the 10th power, and you can do this using your calculator. When you do that calculation, you should get 1.249203426. And we want to keep the entire decimal. Do not round the decimal at this point, or your final answer will have rounding error. You only round decimals when you reach your final answer. Lastly, we're going to multiply that decimal to 15,000. When we do that, we get 18,738.0514. Since this is a monetary value, I'm going to round to the nearest cent. So my final answer is $18,738.05. Part B asks us to find the value of the investment if it was compounded quarterly. So quarterly means 4 times a year. Therefore, our n in this case will be 4. All the other values stay the same. So our principal is $15,000. R, which is the interest rate, is 4.5%, but remember we need to divide by 100 to convert it to a decimal. So we have 0.045, and then T, the number of years, is 5. I'm going to take those values and plug them into my formula for A. So I have A equals 15,000 times 1 plus 0.045 divided by 4, all raised to 4 times 5 power. The first thing we're going to do is divide 0.045 by 4. When we do that, we get 0.01125. Next, we'll add 1 to that decimal in parentheses. And I'm also going to multiply the 4 times 5 in the exponent position. So now I have A equals 15,000 times 1.01125 to the 20th power. Now we'll take our calculator and we'll raise 1.01125 to the 20th power. Next, we'll multiply the decimal that we just got, which is 1.250750521, by 15,000. And we get A equals 18,761.2571. And since this is a monetary value, I want to round to the nearest cent, which is the second decimal place. So here I have a 5, but since the number next to the 5 is a 7, I'm going to round that 5 up to a 6. So my final rounded answer is $18,761.26. Part C asks us to find the value of the investment if it was compounded monthly. Since there are 12 months in a year, our n in this case is going to be 12. And again, all other values stay the same. So our P is 15,000, our R is 0.045, and T is 5. So my first step is to substitute all of the values into my equation. Next, I'm going to divide 0.045 by 12, and I get 0.00375. Now I'm going to add 1 to that decimal in parentheses. I'll also go ahead and multiply the values in the exponent position. So 5 times 12 is 60. And then my next step is to raise 1.00375 to the 60th power. When I do that, I get A equals 15,000 times 1.251795821. Lastly, we'll just multiply those two values together, and we get 18,776.93731. Again, I want to round to the nearest cent, which is 2 decimal places. So I have a 3 in the second decimal spot, and I have a 7 next to the 3. Since 7 is greater than 5, I'm going to round the 3 up to 4. So my rounded answer is $18,776.94. Part D asks us to do this compounded continuously. Whenever we're asked to compound continuously, we use A equals P times e to the RT formula. So the variables stay the same, and we're just going to plug them into that formula. The first step is to multiply the exponents together. Next, you want to look at your calculator and identify E on your calculator. E is just a natural number, and it's a decimal number. It has a really long decimal expansion, and it goes on forever. So the calculator has that decimal programmed as the letter E. So you'll just find that button, click E, and then raise it to the 0.225 power. When you do that, you should get 1.252322716. Lastly, you'll multiply that decimal to 15,000. You should get a value of 18,784.84074. Now again, we want to round this to the nearest cent, so our final answer is $18,784.84. And that's our answer to part D.